Right, so we are back with molar volume and now we are going to practice some questions. So before we practice the questions, let's go through the formula again. So molar volume states that for every 1 mole of gas, must be a gas, right, is equals to 24 dm cube. So that is what molar volume is. So basically the formula is the number of moles of gas is equals to the volume of gas in dm cube, right, divided by the molar volume. And the molar volume is 24 dm cube only at room temperature and pressure. And we talked about it. If the temperature goes up, the volume will also expand and go up. If the pressure goes up, the volume will go down. So molar volume is not always 24, but for our syllabus, when it's room temperature and pressure, it is 24. So let's look at the first question. Calculate the volume and mole of gas at room temperature and pressure. So now when it's all gas, we don't need to care about molar mass. So we need to check whether it's going to be molar mass or molar volume. So now all these are gases, so straight away molar volume. So calculate the number of moles of 36 dm cube of oxygen. So molar volume said that 24 dm cube of any gas is equals to 1 mole of gas. So just using by the ratio method, 24 dm cube is 1 mole. So 36 dm cube, how do I find this? Is 36 divided by 24. So I believe this is equals to 1.5 mole of gas. Okay, so this is the ratio method. Let's try the next one. Calculate the number of moles of 0.6 dm cube of methane. Again, methane is a gas, so I just need to use molar volume, 24 dm cube. So number of moles in 0.6 dm cube. So let me try using the formula. So formula states that mole is equals to volume in dm cube divided by 24. Okay, 24, the magical number. So the number of moles of 0.6 dm cube of methane. So over here, I want to find mole. I got volume. So this is equals to 0.6 divided by 24. Right? And my calculator states that 0.6 divided by 24, it is equals to 0.025 mole. Okay, so that is how we find using the equation. Let's try another one. So now I'm given the amount of moles. So 0.05 moles of ammonia. Ammonia again is a gas. So we want to find volume. So we can find volume of gas using molar volume. So over here we know that molar volume states that 1 mole of ammonia is equals to 24 dm cube of ammonia. So if 1 mole is equal to 24 dm cube, 0.05 moles of ammonia is equals to 24 times 0.05 mole. So this again is a simple ratio thing. I use my calculator, 24 times 0.05, that is 1.2 dm cube of ammonia. Okay, let's try the next one. 0.75 mole of sulfur dioxide, find the volume. So this time I will use the equation method, the formula method. So formula states that mole equals to volume divided by 24. Now I want to find volume. So volume, bring the 24 up, is equals to mole times 24. So I want to find volume. I have number of moles given over here. So moles is 0.75. Magical number at room temperature and pressure is times 24. So put that into the calculator, and that's 18. Unit will be dm cube. Okay, so these are the simple basic questions that we can do. I hope you have been following and copying it down. Now let's look at something a bit more challenging. Now, I'm given looking at part 5. Find the volume of 8.8 grams of carbon dioxide. Now, it's a bit strange because carbon dioxide is a gas. They want me to find volume, but they do not give me moles. They only give me mass. So, the strategy for solving this type of problems is that I will need to first take mass, convert it to moles, and for moles, convert it back to volume. So now let's think and recall. Okay, what must I do to convert mass to mole? Okay, pause the video to think about it first. Yes, when I want to convert mass to moles, I need to first divide it by molar mass or the MR. And if I want to convert it back from mole to volume, what I need to do is to multiply by molar volume. So, must you remember your ratios and remember your formulas, remember the concepts well, so they can do this. So let's tackle this question. So I have 8.8 grams of carbon dioxide. So firstly, I need to find what's the MR of carbon dioxide. So MR of carbon dioxide is 12 plus 16 plus 16. Just to recall why we find MR is because you want to convert from mass to mole. So this is equal to 44. Now to convert from mass to mole, I know this is molar mass. So molar mass states, right, that 44 grams of carbon dioxide is equal to 1 mole. Right, 44 grams is equal to 1 mole. So over here, now I have 8.8 grams. So 8.8 grams of carbon dioxide, right, is equal to what? So it's 8.8 divided by 44. And my calculator says 8.8 divided by 44 is at 0.2 moles. So now I know that I have 0.2 moles of gas. So now to convert from 0.2 moles of gas to volume. So I need to use molar volume. Molar volume tells me that 1 mole of any gas is equivalent to 24 dm cubed. So now I have 0.2 moles of gas. How many dm cubed is that? So what do I need to do? I need to take the moles, multiply it by the magical number 24 molar volume, and I will get 0.2 times 24. I'll get 4.8 dm cubed. Okay, so this is the strategy that we use to solve such problems. I believe the textbook will have more examples for you to try later. So all the best. See you later.